All right. You go to Yosemite, you go through the valley, but that's about as much time as it will take. Okay, go ahead and cut it, or are you still running? Oh, okay. Well, she can edit it out. Okay. All right, turn it off. Well, you can always turn it up later after we... Full feature.
Hi, my name is Glenn Egan. I'm Santa from the group, and I'm from Oakley, California. My project that I brought to share with the crowd today are the 813 monoblock amplifiers. They're beasts. That's about all I can say. Thank you.
All right, I'm Gary B. on DIY Audio. I'm from the San Francisco Bay Area, and we probably have the cheapest system here. We're using Pioneer speakers, which cost about $100 each. We're using the Amp Camp amplifiers that Nelson Pass designed, and I designed, or built anyway, the DIY DAC here, which is a WM8804 DAC with an ES9023 board. And it sounds great. I'll turn it on, and you can listen.
I'm gonna use it, and I'm never ever coming back. Baby, didn't I love you about as hard as anyone could? Baby, didn't I hold you whether you were bad or good? And baby, didn't I...
Okay, hello. My name is Jan Didden, and I'm the publisher of a audio technical magazine, Linear Audio. Normally I come here building something, showing something that I've built. I'm a DIYer as well, of course. But this time I have something to show that I thought is very, very nice as an illustration of how our brain listens to music. The thing is called the Smith Realizer, and it has a kind of a science fiction-like mode of operating. It uses a regular headset, and on the top of the headset you place what is called a head tracker. And the head tracker is a source that emits light, and if you can move the camera over there, you will see on the board the receiver for the head tracker. And you see when I move the headphone, you see the lights move, which means that the system controlling it detects the movement of my head. Now what happens is, normally when you listen to headphones, the sound's more or less in your head. Because when you turn your head, the sound doesn't change, which tells your brain it's inside your head. And that gives a kind of an unnatural sound. You don't have the sound stage like you have with speakers, between two loudspeakers. Actually, with this thing, when you turn your head, the system moves the sound stage to the opposite direction as your movement. So it seems to your brain that the sound stays in the same location. And you get the impression that you're really listening to loudspeakers instead of listening to a headphone. The thing is called the Smith Realizer. It's a quite revolutionary device. It's still a little bit expensive, $3,000. But I demonstrated it to several people today, and some of them took off their headphones and they looked at me and said, "Oh, it was the headphone." So they were so convinced that they were listening to speakers. So very enjoyable, and I had a great show, and I had a great number of people talk about this thing. Is that okay?
Okay, my name is Brian Levin. Online I go by the handle of LinuxWorks, and my company name is Secona Audio. Stands for Serial Controlled Audio. And what I have here is some DIY things that I've either built or designed. First thing is the Alpha 10 preamp. I work with my partner T-Con to put together an Arduino-oriented system that is open source. We sell the boards and some components. We have a website which describes how to build it, gives some insights into the firmware, lets people do modifications, help them assemble it. But basically, it's an LCD controller, an attenuator relay that does basically half dB steps at 127 dB range, discrete power supply, discrete output buffers, and you can control it from the front via the linear pot. You can use the infrared remote. It modifies the position of the motorized pot. There's a port on the back that lets you do web remote control, so you can actually control the system using an Arduino, using an Android system. And the same technology within the controller here is also within my preamp as well, the Secona Preamp. This is a 2-channel system. This is more of a multi-channel system. So this is an 8-channel system using the Cirrus 3318 volume control chip. Same Arduino controller, same basic architecture, but instead of talking to a relay controller, you're actually talking to the 8-channel solid-state Cirrus volume control chip. And it uses the same user interface style. You can come in through the web, you can use a rotary encoder, you can use a learning remote, basically any kind of remote on the market. I'm using a Sony remote, but you can use basically anything. This one is not available as a kit yet. This one is still an R&D project, so this is all done by hand. It's still in the process of being fully designed. But this one, all the green boards are available on AMB's website, so people can buy these and assemble them, and if you need help, go to the amb.org website. What else do I have here? I've got a USB audio widget. So my audio path is from a netbook, USB into the audio widget. The audio widget has a modification that I put in that gives me an SPDIF out, so it's a Wolfson SPDIF transmitter chip. Gives me either optical or coaxial out. Comes out of there into the AMB Gamma 2 DAC. The DAC will go into my preamp, from the preamp into the Beta 22 headphone amp, and then into my HD 650 speakers. And that's the basic flow of what I've got here.
Hi, my name is T-Con. I'm based in Sunnyvale, California. Today I brought basically a whole system that's all DIY, well, except the computer. So I'll start with the source. The computer serves as the source. All the files are on the computer. I have a whole bunch of FLAC files, some of which are high-res. The computer feeds the Gamma 2 DAC. The Gamma 2 DAC is based on the Wolfson WM8741 DAC chip. It's upsampling. And the analog outputs of this DAC goes into this preamp, the Alpha 10 preamp. The special thing about this preamp, as Brian had talked about earlier, is that it's based on Arduino clone controlled system. It's got a relay-based attenuator for the volume, and also a relay-based input and output selector. So as opposed to an ordinary potentiometer for controlling the volume, or even a stepped attenuator, this one uses relays to switch precision resistors to get you the volume change. And in this system I have 8 relays that gives you up to 256 steps at half dB per step. The input and output selector is also relay driven. There are a total of 8 ports that you can assign arbitrarily as inputs or outputs, up to a total of 8. So what you see in here is an integration of that system plus the Alpha 20, which are these little modules that are actually the preamp active buffer itself, and also the Sigma 22 regulated power supply, which is a very low noise dual tracking power supply. And the Arduino based circuit board is called LCduino, and it supports remote control as well as a front panel control for the volume. So moving on, what we got here is a power amp. It's called the Beta 24 power amplifier. The topology is a fully differential circuit. Basically, that means the loudspeaker terminals, both terminals are actively driven, and the signals are out of phase with each other. What you get is effectively double the voltage swing on the output. And the circuit is also fully complementary, so it's a 4-quadrant amplifier per channel. The advantage of this circuit is pretty well known. It cancels distortion and all that good stuff. The input stage uses JFETs. The voltage amplification stage uses BJTs, and the output is MOSFETs. And it's got a big power transformer. It has pretty good power and current capability. And these are driving a pair of DIY speakers that are based on the Dynaudio Esotec drivers. So that's it.
Yes, my name is Kerry Chen. I live in San Francisco. What you're looking at is my system that I bought today. First off, this is a Fostech single-ended driver speakers with no crossover. Next, the heart of the system is the bottle-head single-ended experimental amplifier. 1 tube per channel. It puts out approximately 2 watts per channel. Next up is a Marantz CD player. Anything else?
My name is Mario Irun, and I live in San Rafael, and I made these pencil cabinets for the Mark Audio 12P, the 12P paper. And we've been listening them today on Carrie's wonderful Sex amp. We also were listening to them for a little while on the Amp Camp amp over there, and just had a wonderful time today.
My name is Nelson Pass. I represent First Watt and Pass Labs, but here at the Burning Amp Festival, I represent DIYers and their ilk. And we have a nice setup here with a nice room with good acoustics, and we have brought a bunch of equipment, and I will be happy to tell you what those things are. We're running an Oppo player, which is playing wave files from a USB memory stick. It's going. The signal from that is going out to, at this moment, an electronic crossover, which is a product that I happen to make and sell called a B5. It is driving this pair of speakers, which are these open baffles with Louthers, and there are Eminence 15-inch drivers, which are slot-loaded in the bottoms, and they are crossed over there at an acoustic center of about 160 hertz. And at this very moment, a gentleman who brought his F5, which he built himself, brought it in, and we have hooked it up, and we're listening to it on the top end. And I am sharing the room with Dana Brock, who is Nelson Brock's father, and they have sponsored the Loudspeaker Camp and the Amp Camp events, of which I personally participated in the Amp Camp. But the Loudspeaker Camp is a thing where something on the order of 20, 30 people show up, build speakers all day, and at the end of the day, everybody goes home with a pair of speakers. In the case of the Amp Camp, it was the same thing, but at the end of the day, they went home with a working amplifier, and I'm happy to say that that was my design. We've got a couple of those. We've got actually numerous examples of those here. The ones that you can look at are the fire engine red ones that are parked over there. Next to them is my science project, which is, okay, those are the Amp Camp amps, and those are kits sold by DIY Audio. Next to that is a 3-part amplifier, which is my science project. The amplifier channel each consists only of 2 transistors and 1 transformer and no other part, and a lot of power supply, as you can see off to the sides there. And then we have a whole bunch of different kinds of full range loudspeakers that have been put on demo here so that people who are considering trying different types of drivers are in a good position to get a good listen to them, think about what it is that they might want to try doing before they have to make the investment. So it's a nice opportunity to go through and listen to a number of examples of things that they can do. And we have a nice little audience, and this is my friend Scott, who attended, actually a couple of years ago, 2 years ago, had dinner with us. And a bunch of other people, and you can see how they treat the rooms with moving blankets. And let's see, over there is the, in red, is the gentleman who built the F5 that we're listening to, and that's my wife Jill. And down below her, there is my dog Jack. And there's Dana Brock, and these are all those speakers, full range, that are his. And these two gentlemen, I don't know where they're from. And here's Jason, who is the head of DIY Audio. And now you've seen it all, folks.
Thank you. Have a good day.